prove that there are an infinite number of primes. Now once again we're going to use a contradiction, so we're going to assume there is a finite number of primes. And if there's a finite number, then we could label them P1, P2, and so on up to Pn. Let's suppose there's n primes. Now there's a trick to this proof. If you know the trick, it's easy. If you don't know the trick, then you'll probably never get it. So we're going to define a number n, which is equal to 1 plus P1, P2, P3, up to Pn. So this number n is going to be all of the known primes, or all of the primes that there are, because we're saying there's a finite number, multiply them together and add 1. Okay, so there's two possibilities. Either n is prime, and that's a contradiction because n is not one of P1 up to Pn. It's a different number. Or n is composite. But the problem there, n does not divide by any of P1 up to Pn. You need to look at how it's constructed. Any of P1 to Pn would divide here, but they won't divide 1. So therefore they can't divide the number n. So that's a contradiction, because there must be another prime which is the divisor of n. So we get a contradiction whether n is prime or whether n is composite, and therefore we can't have just a finite number of primes, so therefore there must be an infinite number of primes.